In this video, we'll look at implementation of stack using array, that is stack using array. We have already seen ADT in previous video. There we saw for a stack, definition of stack, we require data representation and then the operations on that data. So first of all, we need representation of data. So for implementing a stack, what are the things required when you are using an array? Look at this. I need a fixed size array. So I have taken an array of size 5 here. So this is the size of a array. So we need a fixed size array, and also we should know what is the size of that array. So I have one variable in which we can store size of an array. Then we need a top pointer to point on the topmost element. So yes, I have one more thing, that is top. So what should be the data type of this one? Integer, because it is pointing on the index. Whichever is the recently inserted element, there it will be pointing. So that is the index. Integer type. Then this array depends what type of values you are storing in this one. So we need total 3 things. We need a array of some size, and we need the size, and also we need a top pointer. 3 things we need for implementing a stack. Then one more thing. Inside the stack, we insert and delete the element from same end. Insertion is also done from top and deletion is also done from top. We say like this. So from same end we insert and delete. So here an array is having 2 ends. See, from this side also you can insert, this side also insert. What does it mean by this, inserting from either side? So I will write few elements and show you. Suppose I have few elements 10, 15 and 7. I have few elements. Then I want to insert one more element, that is 20. Where I should insert next element? Here or here? If I am inserting here means I should shift all these elements. If I want, I can insert. But which is better? Inserting this side is better. Inserting this side. So we can say that this side the insertion and deletion is done. So if you remember, in one of the videos I have shown you insertion and deletion from that side is constant time. It takes constant time. If you say that no, every new element will come here only and we should shift the elements, then we are inserting from this side. So it will be order of n. So better we insert the element from this side. So let us quickly see what all we have learned. We require an array, we require size, and we require top pointer, and the elements will be inserted from this end, always from this end. And the top will be pointing upon topmost element. So suppose top is this one, so top will be pointing on this one, topmost element. Then how all the operations are performed, we will learn that one. Then one more thing. When we are saying stack, we usually imagine that it is vertical. It is vertical, like a can of balls that was vertical, or grain bags which are piled up one above another, that is also vertical, or a shunting yard that is on railroad, that was also vertical. And in recursion, at many places we have seen the stack, so that was also vertical. So usually we imagine a stack as vertical, so that array I am showing it as vertical. So we will be drawing vertical array whenever we say stack. Actually it's a normal array only, right? But to clearly see how it is working, this orientation is better. So we will be using this orientation. Actually it's an array, simple array. Then based on the things required for a stack, we require 3 things, right? We require 3 things, first, second and third. So for this, we will combine them together and we define a structure, like how we have been doing in the previous topics. So related things grouped under one name, we can define a structure. Let us define a structure for the stack. I will define a structure for stack. Let us call it as a stack. Then what are the members we require? First, I will take size, integer size. Then also I will take top pointer also, top pointer. So this is top. Then I need an array. So shall I declare a some size array directly, or shall we decide at runtime and create the array? We will decide at runtime and create the array. We will find out what is the maximum expected size of the stack and we create an array of that size. So then better take it as a pointer. Don't take a fixed size array, so that we can dynamically create a stack. So what are the type of elements that I will be storing? Mostly for learning purpose we use integer type only. So I'll use integer type array. So for that I will declare a pointer. So this is integer type pointer. So I'll be using this structure wherever I'm using stack. So we'll follow this structure. Structure is having three members. It's a size and its top pointer and the pointer to an array. That array will be created dynamically. Next, let us see how to create this and initialize this stack. Inside main function, I will create the object of this, that is stack. So I will take a variable simply. So struct stack st. So st is a stack. Now once this stack is created, there are three variables in this one. So we'll get an object that is st having three things inside, that is size and top pointer and s is a pointer. Three members are there. Now I should know what is the size because this array is not yet created. Array for storing element is not yet created. I have to create it. So I should know the size. So let us take the size as input from the keyboard. So I will write down, I will say printf enter the stack and I will scan this size value, that is st.size. So here I have written printf enter size of stack, then scanf read the value. Suppose the size of the stack is given as 5, then this size will be 5. This size is 5. So let us assume that this is 5. Now when we know the size, I should create an array of size 5 for storing the elements. I should create an array. Already I have a pointer. So let us create an array here and assign it to this pointer. So here is the code st.s. To leave this, first let us read this. New int array. So create a new array from heap, new means heap. Of what size? st.size. So this is st.size 5. So new int of size 5. So an array is created and its address should be stored where? Here. So what is this? st.s. So st.s assign new int st.size. So an array is created and it is assigned here. Then one more thing I have to do. We know that top points on topmost element. Where is the topmost element? There is no topmost element. Then where top should point? It should point outside the stack. It means there are no elements. If the element comes, then it will come there. So where the first element may come at index 0, then where top should be before that. So let us take one more index here. This is not there in an array, just we are labeling it as index -1. So top should be at -1. So I should initialize this top as -1. So we say that top is pointing here at -1. So initially top should point at -1. So I should write on that code. So st.top assign -1, assign with -1. So these are the statements that will make our stack ready with this complete structure. Size is there, top pointer is there, and an array of required size is also created. So we are using entire thing as a structure. This is a structure. So next we will be looking at how we perform the operations on the stack where the array is like this. So we'll not be looking at this diagram every time. So the simple diagram we will see, that I will show you. So this is the structure that we'll be looking at every time whenever we say stack. So there is an array of some size I have taken and this is size is 5, and top initially it is at -1. As we go on inserting the element, it will be moving and pointing on the topmost element. Now let us look at two important things here. When do you say this stack is empty? So right now it is empty. So what is the condition? See, top is equals to -1, then stack is empty. So yes, condition for empty is if top is equals to -1, then the stack is empty. Then when I say that stack is full, if all the elements are there and the top is pointing on this location, beyond this there is no space. So what is this location? Size -1. Stack full condition is when top is equals to size -1 at this location. So I will write on full condition. So top is equals to size -1 is a stack full condition. So we know the conditions also. So we'll be using these conditions wherever required. Now next let us look at all the operations one by one. I will explain how the operation is performed and I will also show you the program code, that is the function for doing that.